Hey, welcome everybody. We're going to be finishing up chapter 4 with relative motion, and if you're seeing this, we probably already talked about it a little bit in class, but this is going to be example 4.9, and it's going to be based off the idea of the velocities of two different objects being related to each other with respect to a third object. For example, I think we said in class, velocity of object 1 to object 3 is equal to, the velocity of object 1 to object 2 plus the velocity of object 2 as it relates to object 3. That means if we have a car, or say two cars here, there's a very poorly drawn car going that way, and there's a tree right here, and then another car. That looks like a tornado, actually, but here's another car zooming towards that. We might say that each car has a velocity of, 30 meters per second. But that velocity, that is, if you're in the car and you're seeing that on your speedometer, 30 meters per second, that velocity is with respect to the ground, or with respect to an object that is not moving, like the tree. So this car here is moving 30 meters per second with respect to the tree, and so is this car, but the two cars with respect to each other are moving, you would say, 60 meters per second with respect to each other. They're approaching each other at that speed because they both have a velocity. That basically sums up what we're talking about right here in this equation. If this is object 1, object 3, and the tree or whatever stationary object you choose it to be is object 2, that means that the velocity of object 1 to 3 is the velocity of 1 to 2 plus the velocity of 2 to 3. So what we're going to be doing is taking that and using it to solve example 4.9 in our notes. So let's take a look at this. We have a person climbing a train. So here's a box car of a train right here, and it has a velocity of what? The train is moving at 5 meters per second. Okay, 5 meters per second. Well, relative to what? Relative to the ground. In fact, most things that we measure their velocity with respect to the ground. But we have a person climbing it, and so they're climbing up a ladder right here. And they're moving upwards or vertically at 3 meters per second. Because they're climbing up the side of the train at 3 meters per second as the train itself is moving at 5 meters per second. So the person is moving with respect to the train is moving with respect to the ground. So the question is, what velocity does the climbing person have with respect to the ground? So let's write down our velocities and let's put some subscripts so this actually makes a little bit of sense right here. Let me erase this little mark there. So what we're really saying is that the velocity of the person to the train, and get used to start writing these subscripts here, of the person to the train is 3 meters per second. And let's put it in unit vector notation as well. 3 meters per second in what direction? Well, that's easy because it's just in the vertical direction. So we might say 3 meters per second y hat. They're moving vertically with respect to the train at 3 meters per second y hat. Well, what other velocity do we know? We know the velocity of the train with respect to the ground. Velocity of the train with respect to the ground, velocity TG, and that is 5 meters per second. And since it's moving horizontally, or it's moving in the x direction, we can say that is x hat. Now, if either of these two objects were moving at a different angle other than horizontal or vertical, we would have an extra step required to break it into y and x components, but this right here makes it easy for us. We have a person climbing in the y direction and a train moving in the x direction. So the question is, what is the velocity of the person to the ground? That's what we want to know. And again, if we write down our equation from before, velocity 1 to 3 is the velocity 1, 2 plus 2, plus velocity 2, 3. And the order in which we write these is actually very important. Velocity 1, 2 is the opposite of velocity 2, 1. And then we'll discuss that more in class. But anyway, this is what we're basing off of our problem off of right now. So what we want to know is the velocity of the person to the ground. That's what we really want to find out. Well, that equals the velocity of the person to the train plus the velocity of the train to the ground. So we can take these two, we know that, and we know that, and we can actually put it in unit. It's already in unit vector notation, so it'll be easy to resolve into a final magnitude for our velocity PG right here. So let's just do that right now. Velocity of the person to the ground is equal to what? Well, 5 meters per second x hat, that is, it has an x component of 5 meters per second, plus 3 meters per second y hat. So the person moving with respect to the ground has a horizontal and a vertical component. So that's how we would state the person's velocity with respect to the ground in unit vector notation. But now let's take this x component and this y component and simply resolve it into a magnitude. So velocity of the person to the ground, I might say magnitude, is what? Well, it's the square root of the x hat squared, plus the y hat squared. Sorry, my computer's a little jumpy here. Right? That's basically the Pythagorean theorem. So the x hat squared, that's 5 x hat squared. I'm leaving the units out for simplicity right now. Plus 3 y hat squared. All right, we've got our x component and our y component. Square them both, add them together to take the square root, and that gives us our resultant magnitude. And that should be 5.8 meters per second. That is, as the person is climbing the train, they're going vertically and the train is moving horizontally. They're taking a path kind of like that. They're moving up and the train is moving over towards the right. And so with respect to the ground, they appear to be moving at 5.8 meters per second. But it's also neither horizontal nor vertical, but it's at an angle with respect to the ground. And we can figure out that angle. We know how to do that. The velocity of the person with respect to the ground, you might say the direction, dir, is what? Well, if we have an x component and a y component, we know how to do that using the inverse tangent. The inverse tangent of y hat, oh, come on now, over x hat. All right, so that's the inverse tangent of 3 over 5. The y component over the x component. Inverse tangent, and what do we have? We have 31 degrees. 31 degrees. And let's go back and look at our diagram right here. What might we say that direction is? Well, he's moving where you might call east, and we can say up is north, so that would be 31 degrees north of east. North of east. So that's our first problem. Our first solution to our first problem of how to solve for relative velocity. The velocity of the person with respect to the ground is 5.8 meters per second at 31 degrees north of east. That should be it for this first problem, and I'll see you on the next one.